good afternoon, or good morning, depending on where you're at. I just wanted to let everyone know that I'm seeing everyone still logging on here to this webinar. We're going to give another minute or two to allow some of the people that are entering in the webinar to go ahead and do so. So we'll be just starting the broadcast in another moment or two. Thank you for your patience. Okay, we're going to get started for today's presentation. Thank you all for arriving on time for today's presentation. My name is TJ Willits from Wastewater Technologies, and I'll be your moderator for today's webinar event entitled Wastewater Treatment Using High Performance Technologies for the Food and Beverage Industry. Our presenter today is Greg Rosenberger, who you'll meet in a few moments here. Before we enter into our presentation, I just have some intro slides to go through with you. It's obvious that you should be hearing me speak now. There are two ways to listen to today's webinar presentation. One is through your computer, or you could also use your phone, and you could toggle that on to the right side of your panel there. You could pick if you're having audio problems and try the other one if you are having issues with the audio. Just one other note as well, since there's so many people online for today's broadcast, over 100 and some, your microphone is going to be automatically muted. But don't worry, we have thought another way for you to interact with today's panelists for today's webinar. And what we have is we have an interactive Q&A scheduled for after today's presentation. And to go ahead and ask a question, you'll see on the right-hand side there should be a question box. Simply just enter in it. It's a chat box, and go ahead and enter your question. Feel free to do so throughout the entire presentation. We'll try to prioritize and get to as many questions as possible with our panelists after he's done presenting the main part. And if you weren't aware, today's presentation is one of our 3-week live webinar interactive series. You can see some of those on the right-hand side. This is our 3rd webinar in our series. No worries, you could go ahead and catch the other ones on demand at our website. Also, you could go ahead to our website and register for any of the other webinars that you might find interesting. And again, our website is at veoliawatertech.com, and you could head over there and sign up for any additional webinars. And in addition to our live webinars, we also have made public our 30+ or so webinars from the last few years in an on-demand webinar library that's at our website as well. So you could go ahead and watch those webinars right online at your convenience at any hour 24/7, and that's at our website. One thing we're doing for this webinar series is we're offering PDF participation certificates. How that will work is the system will automatically send you out a certificate via email, PDF certificate that you could print or save if you wanted to use this time for continuing education credits. Again, it'll come to your email probably tomorrow around the same time as now, and you can go ahead and save that. And let me know if you have any questions or problems with your participation certificate. And one last slide about housekeeping here is we have a survey that will be presented to everyone in attendance after the webinar. Something fun we're doing for this series is we're offering a $25 Amazon gift card for anyone that, not anyone that fills out the survey, but we're going to put everyone into a raffle and you'll be entered in to have a chance to win a $25 gift card. So any participant will let you know in about a day or two if you've won that drawing, but we want to use the feedback to make these webinars as beneficial to you as possible. So if you have topics that you want to see presented, there's a place to go ahead and do that, and also just provide some general feedback about today's presentation. Okay, a little bit about Veolia Water Technologies before we hop in. Veolia is a leading environmental company. It's a global company. Our group that's presenting today, the Water Technologies Group, we sort of focus our efforts into three key main areas: technologies, projects, and services. So we have a large portfolio of technologies that we could use and bundle together to provide quality water and wastewater treatment for our clients. And then, of course, we have a wide range of services that support our clients in their day-to-day operations. Okay, now it's time to transition to our core presentation for today. I'm going to introduce our presenter, our panelist, Greg Rosenberger. Greg Rosenberger is currently the VP of Veolia Water Technologies Philadelphia office, which is the center of Veolia's Industrial Biological Wastewater Treatment Center. In this role, he's responsible for developing solutions for industrial wastewater applications, including process selection, system design, mass balances, lab and pilot testing, and also the startup of facilities. He has 20+ years of experience in biological wastewater treatment in a broad range of industries, including food and beverage. During his career, Mr. Rosenberg has served as a process engineer, project engineer, commissioning engineer, technical director, and a lot of other roles as well. So at this time, we're going to welcome Greg Rosenberger to provide the presentation for today's webinar. Greg, are you with us?
Yes, I am. Thank you, TJ. Hello, everybody. As TJ mentioned, my name is Greg Rosenberger, and I've been working in the food and beverage industry and the wastewater side for over 20 years, and I'm happy to give this webinar series today from my lovely bedroom, probably like a lot of you guys are at home in your dens or bedrooms, or at the work from home situation going on right now. From agenda today, we're going to hit a couple core topics. We'll have a brief look at just some understanding some food and beverage wastewater, some terms, looking at a little bit of the technology. Then we're going to go into what are some of the key wastewater project drivers that we're seeing out there and why people are actually putting in wastewater projects. We're going to look at different types of technology out there, primary treatment, biological treatment, and anaerobic and aerobic systems, membrane technologies. We're going to look at an interesting small evaporator technology for point source treatment. We're going to look at some case studies. Where are your contemporaries applying these technologies and what do their projects look like? And then after, we're going to finish up is just to look at some things. If you're thinking about a wastewater project, what are some things that you would have to think about, some things you should do to help the technology supplier better provide you with the best solution available. To start off, when we look at wastewater treatment, you'll find, if you don't know already, there are a tremendous amount of acronyms and terms that we use out there. We just sort of say them right off the bat, assuming that everybody knows what they are. We found through some of the feedback that sometimes people don't know all these terms that we're throwing around. So we just have a little glossary here to start with. You'll see some of the key terms you see here that are used all the time. COD, BOD, being the chemical oxygen or biologic oxygen demand, really what measures the strength of your wastewater. TSS, total suspended solids, pretty self-explanatory, the solids in your wastewater. You have a lot of different types of technology that all have acronyms. UASB, EGSB are different anaerobic technologies. DAF for dissolved air flotation. MBR for membrane bioreactors. MBBR, which a lot of people confuse MBR and MBBR, the difference between a membrane bioreactor and a moving bed biofilm reactor. And for a lot of you people, especially in the dairy industry or in the meat process industry, FOG, fats, oils, and grease. So here's a couple of the key wastewater terms. We use those a lot in the wastewater industry. When we think about food and beverage wastewater, and we look at what does that consist of? A lot of sugars, carbohydrates, fats and greases, proteins, ammonia, other compounds. These are the things that a lot of times are going to be in your raw wastewater that create some of those COD, BOD, TSSs. Some of the unique challenges in the food and beverage industry, pH swings. When you do CIPs, obviously a lot of times you come down with extremely high pHs that need to be understood. Temperature. Are you coming down hot? Are you coming down cold? Biological wastewater treatment is very dependent on temperature. Anaerobic treatment likes hotter temperatures around body temperature, 98.6, 99 Fahrenheit. Aerobic systems can run at a wider range of temperature. Variability, there's a lot of variability, especially for batch treatment production facilities and the strength and the flow of the wastewater that comes down. Seasonality, look at some of the vegetable producers, they have huge production in certain parts of the season and very little in other parts of the season. Salinity, what is your salt content? What is your chloride content? A lot of times that comes into play when we look at materials of construction. If you have high chlorides, potentially that could make stainless steel an issue. So there's a lot of unique challenges in the food and beverage industry and across different portions of that industry that we have to take into account. Why do we do this in the end? Why do we treat wastewater? Not to get on the soapbox a little bit, but obviously it needs to be treated because it has an oxygen demand that if you just put it directly into a receiving body, the bacteria would eat that oxygen in the water, and then it would kill the fish. It would cause other detrimental issues. A lot of N&P people who eventually go into large, like the Chesapeake or Delaware bays. You could have algae blooms or lake eutrophication around your nutrients. So there's a lot of reasons why we need to treat our wastewater, and there's that ever-evolving targets and regulations that need to be hit as those limits become more strict and more strict over time. So what are some of the key project drivers that drive the food and beverage industry to do projects? I would say number one typically is sewer surcharges and sewer violations, notice of violations. If you're not going direct stream discharge, most food and beverage facilities still put their wastewater into a sewer system. You have to pay money for that. You might have limits for that. So a lot of times the reasons that people are looking at it is try to have an ROI project to reduce your sewer surcharges, or the sewer authority through notice of violations is forcing you to put in a pre-treatment plan. Corporate sustainability, there's a lot of large firms out there that have corporate sustainability efforts that they are requiring some level of pre-treatment before a sewer, or they're looking at water reuse type of situations. Facility expansion is always a big one. You're putting in an expansion project, you're increasing your production capacity by 25, 50, 75%, and the sewer authority or your existing wastewater treatment plant cannot handle it. So you need to include wastewater treatment plant expansion in the total facility expansion. And another thing is future proofing. There are some clients out there that we are seeing that we're going to do a wastewater project. We don't want to do it just for today. We want to put in a project that's going to last 10, 15, 20 years. So we have some more people now looking at, okay, what are my expansion plans out over time, recognizing that it might cost a little bit more right now, but to increase the volume of a tank or to increase the volume of a pump is very small compared to adding a second whole tank or pump in the future. So we have more people now looking at, it might be a $3 million project, but if I add another $500,000 or $1 million or increase it by 20%, I can get 50 or 75% more capacity in my system. So when we look at the first drivers, we're really reducing sewer surcharges. How is that going to happen? What do we look at? What are we looking to do? And most of the time that most people are paying on TSS or FOG and BOD surcharges. Almost everybody pays on flow, strength of wastewater with BOD, and solids of wastewater with TSS and FOG. So we're looking to reduce that level of pollution, or sometimes even reduce the flow if we can, try to. And then the secondary one is if you have any nutrient. There's some people out there that do have nitrogen and phosphorus requirements, even some out there now that are starting to have dissolved solids requirements. how do we reduce those? So when we look at sewer surcharges, you're typically looking at what is your sewer bill look like? What are you being charged on, so we can figure out how much money could be saved. When you do, eventually the accountants get hold of it and want to look at an ROI calculation. So what technologies do we use to reduce pollution in the wastewater, reduce those CODs, those TSSs, correct for the pH, etc.? So when you look at wastewater treatment, some more terms you'll hear. You typically look at 3 types of treatment. You'll hear about primary treatment, which is typically equalization, pH neutralization. Maybe you could consider that FOG or TSS removal, screening. That's what you typically consider primary treatment. Secondary treatment, typically you start to talk about biological wastewater treatment and large reductions in the BOD or COD of the wastewater. And then you talk about tertiary polishing. Sometimes when you need to look at even to go to the lower levels of phosphorus or lower the levels of TSS to put even in finer screens. And then there's different types of outshoots from that. Sludge handling, if you have a lot of sludge that you can't just truck away. Looking at potential water reuse back into a cooling tower, back into the facility. Or even some small plants are looking at zero liquid waste or zero liquid discharge, ZLD type systems. So we're going to start off here with primary treatment, something that, most people know what equalization pH is, but if you're looking at dissolved air flotation, which is really around typically FOG and TSS removal. There's a lot of people that have FOG limits. Typically, maybe that could be 200 ppm, 300 ppm. The sewer authority wants you to reduce that because essentially the FOG goes down the drain, it gets into the pipes, maybe it combines with some cold water somewhere, and you start to create the fatbergs. Is what they're called. If you go online and Google fatberg, you'll see some stuff from London a few years ago. They had fatbergs that were tons and tons large over years and years of time. So the DAF is a piece of equipment that is used a lot to remove FOG from wastewater and get it down underneath your FOG limit for the sewer. It also has the benefit that all the TSS and all of the BOD associated with that FOG is also removed. It's a technology where you basically inject air into the waste stream. That air, those micro bubbles, float that FOG to the top of the DAF where it is scraped off. And then the clean water in the underflow is your final effluent. Typically, you will use polymer, some type of coagulant. It's like a ferric chloride, or even sometimes another type of polymer. And then a second polymer that will help facilitate that flotation of material. The main advantages you'll see is TSF and FOG removal. Standard DAS, you pretty much would take an 80 to 90% TSS and FOG removal with proper polymer dosing. And this is done, as I said, to prevent a lot of downstream blockages of FOG in downstream sewer piping. If we go now to secondary treatment, there's a couple different types of secondary treatment that we'll look at. We'll start off with my favorite type of treatment, anaerobic wastewater treatment. When you look at anaerobic wastewater treatment, you're typically looking at a couple different types of treatment. We call them high rate treatments, medium rate, or low rate. Traditional in the food and beverage industry, you're talking about high rate and medium rate levels of treatment. Those would be your upflow granular sludge systems, your UASBs and EGSBs. Medium rate is more of your high rate CSTR systems. The high rate anaerobic technology, granular technology, this is a bellwether in food and beverage. Veolia has over 600 of these systems installed worldwide in the food and beverage industry. The UASB system is very common. You'll see it in the dairy industry and the potato industry. And the EGSB system you'll see in most of the other industries. Typically, these types of systems get 80 to 90% BOD removal and a very compact system. They use a granular biomass. It looks like small peas or caviar. You see that initially from a healthy reactor. And the benefit of this system, unlike a lot of aerobic systems where you have a waste product in your sludge produced, this biomass typically can be sold to other reactors that are starting up or have had problems over time. So you turn a potential liability actually into a product. The key to the system is the internal separators or three-phase separators. This is where all of the patents and proprietary technology lie for the system. These are shop fabricated to very high quality tolerances, and they are then shipped out to the field and installed in the reactor tank itself. Another technology out there that is in the food and beverage industry, especially in the high fat industries, is the methane anaerobic MBR technology. The unique part about this technology is it digests fat and TSS. So a lot of times where if you put a DAF in front, you have fat removal that you have to take account into your system. Having a tanker truck come every couple of days, or depending how large your system is, maybe a few times per day to remove that float. This system actually digests it and then can get that material down to sewer level quality in one step. Some of the main advantages of anaerobic systems is they have compact designs and sizes. They can be built tall. They run at very high loading rates. So you can get 89% of treatment in the fraction of the footprint that you would need for an aerobic system. They traditionally have much lower operating costs. There are no blowers in the system that have a need for power. And in most instances, biogas is created that can be reused within the production facility to displace natural gas. And finally, reduce sludge production. In an anaerobic system, only a couple percent of that BOD removal goes to sludge production versus a typical 35 to 50% in a aerobic system. So the amount of sludge that gets produced is much lower. So a lot of operational cost advantages to going with an anaerobic system. For smaller sized treatment plants, we do have packaged anaerobic systems. These are completely shop fabricated anaerobic reactor tanks. They come with a skid that includes a control panel and the pumping systems. We can shop fabricate the equalization tank. So if you have systems that are smaller in size, a couple 100,000 gallons per day, COD loads that are less than maybe 6 or 7 metric tons of COD per day. This is a very interesting type of system because it can be built in the shop and installed very quickly. So if you need a fast system out and installed quickly, this one is it. And it also, because everything is shop fabricated, is extremely cost effective. If anaerobic treatment is not apropos to your situation because of your influence, or you need very low tight tolerances on the sewer discharge, that you need aerobic biological treatment in back of an anaerobic treatment plant, there's several different ways to do that. First is a conventional activated sludge plant. This is what you see at most municipal facilities. It's been around for a very long time. Essentially, you have a large aerobic aeration tank where you have your blowers in the tank and you blow air up through the wastewater. The bacteria, aerobic bacteria in there, reduce the BOD and COD and TSS in the system. You overflow that into a large gravity clarifier, which basically concentrates the sludge, which you either recycle back into the system to keep the sludge concentration in the aerobic system high, and then that clarifier overflow is your effluent. And then you have obviously your waste sludge. Whatever you don't recycle back into your aerobic tank is waste sludge that would have to be handled either in a dewatering system or trucked away by a trucking system. A second type of technology out there, which is much more compact, is the MBBR technology, not to be confused with an MBR technology. MBBR is moving bed biofilm reactor. Anops Cowdness is the Veolia technology brand name for that. It's been around for nearly 40 years. The interesting thing about this technology is it decouples the clarification from the aerobic system. So you have a plastic media, it's a biofilm-based technology, as you can see there in your picture. The bacteria actually grow on these small pieces of plastic. So you can load this technology at a much higher loading rate, much smaller footprint, and then you can clarify that with any type of clarifier that fits the system best. It could be a gravity clarifier, it could be a DAF system, it could be a ballasted clarification system. So it is a more flexible technology in that sense. The internals to the system are still pretty straightforward. You have an air grid at the bottom of the tank. That air grid is a medium bubble diffuser system. That's one of the advantages with the MBBR. You don't need fine bubble diffusers. You don't have to go in every so many years and change out a whole bunch of discs. It's just a set of metal pipes with holes in it, pretty much. You have your media, which is produced up in Wisconsin in the USA. And then you have your sieves. So you have obviously media in the tank. You don't want that media to just overflow out into your downstream piping. So you have some sieves. Really, they're just big cylinders with holes in them to keep the media in the tank. So pretty straightforward system on the aerobic tank itself. Here's a picture of the media. It looks like honeycomb cereal, if you're familiar with that. A lot of technology actually goes into this media to get the proper buoyancy, to get the exact amount of space that you require in between the plastic to make sure you just don't grow over everything. You have the right biofilm thickness, etc. So there's a lot of actually technology that comes into those. They come out into the site in big super sacks that you just dump into the tank. Footprint, as I said, is one of the major advantages of this system. It can be run very high rate. So you can take things, if you have a big aerobic lagoon, you can bring this down to a fraction of the size. It is much smaller typically than activated sludge plants too. You can build these tanks a little bit higher as well. So if you have footprint issues, that's a key place that these are installed. It's also pretty flexible in where you can put it in. In greenfield sites, we can put in an MBBR system as a standalone system. Let's say you have an activated sludge plant already, but your system is overloaded. You can put an MBBR right in front of it just to take off 30, 40, 50% of the load and then just overflow right into your existing activated sludge plant. So it's a real cheap way to gain pre-treatment or to gain expansion into your existing activated sludge plant. There's sometimes where we can convert your activated sludge plant into an MBBR by just throwing media into the tank and increasing, if you have no room whatsoever, just increasing the capacity of your activated sludge plant by installing media in it. And finally, you'll see some people that have all of a sudden have ammonia limits put on them. You can take your final effluent and just have a nitrification MBBR that converts all of your ammonia to nitrate. Therefore, you don't need to, you can meet your nitrate, your ammonia limits much cheaper. So it has a lot of flexibility in where we install this types of system. The core advantages is it's very reliable because the biofilm grows on the media. So you're not relying on the interaction of a clarifier with an activated sludge plant. So anybody that have clarifiers out there and have bulking problems, there is no such thing as a bulking problem in MBBR. I mean, pretty much if the blower is on, then you are treating wastewater. Footprint, as we talked about, it can be loaded very high, so you have footprint considerations. And also, it's very good for systems that need long SRT. It's a very good system for nitrification if you have ammonia issues. So that's another place it's installed a lot. Next step we're going to look at is tertiary filtration. A lot of times if people are out there and they have an existing treatment plant, but their TSS limits need to be lower, or they need to reach maybe direct stream discharge quality, which is always a very high quality standard. Or maybe you're looking at P removal. You have phosphorus issues now all of a sudden, and you need to remove phosphorus. This is a technology which can make that happen. It's called a Hydrotech drum filter, a Hydrotech disc filter. They're pretty much the same technology, just how the screen is situated within the tank itself. So basically, this is a device that the water flows into the system. It has to pass through this screen size. This screen size can be anywhere from 10 microns up to about 100 microns. When the system starts to dirty, it will start to have a pressure drop and then rotate. And then there's a shower system that sprays off. You can see this filter self-cleaning cycle at the bottom there. It will actually spray off the solids. They are very small footprint compared to a traditional sand filter. They don't have the complexity of a sand filter operation. They have very low power consumption. All that you have is those discs rotating on a very small motor. Very easy to maintain. You can open that system up while it's in operation. It's all under relatively low pressure. You can replace those discs if they get damaged in situ. You don't need to shut the unit down. And we see a lot of these used for phosphorus removal. You can have a coagulation tank in front of it and dose some ferric chloride to precipitate out the phosphorus, and then remove the phosphorus in this filter. So it's a very high level tertiary filter that you would install potentially after an existing clarifier. It is its traditional application. Looking at aerobic MBRs, that's another technology you hear a lot about out there. It can meet very low quality standards. So typically you'll see these installed in two situations. One, if we're looking at going to direct stream discharge, because typically direct stream discharge into a river or a stream or a lake require very low BOD and TSS levels. And two, if you're looking at water reuse, because most water reuse facilities require either very low levels of BOD and TSS, just like direct stream discharge, or they require RO treatment. And you always typically require in a wastewater application UF treatment before RO treatment. So what does that mean? It means you're installing a membrane system as your clarifier. So instead of putting a gravity clarifier, or instead of potentially putting a DAF as your clarification device, you are going to install a membrane. Membranes have extremely small pores. They reject all of the TSS that's coming into the system, which can get recycled back to your aerobic plant, and then you will have membrane quality effluent coming out of the facility. Most membrane systems in a biological environment are submerged membrane systems. They are installed in a tank that actually has the biological contents of the tank in it. You have a slight vacuum on the membrane, which sucks, per se, the clean water through, and the dense sludge then starts to accumulate in that tank and concentrate up. They can be extremely compact. The membrane systems over the past decade have really increased in their technology and the compactness and how much membrane area is required. So a lot of these times, these tanks can be shop fabricated and sent out to the field and do hundreds of thousands of gallons per day in a shop fabricated system. If you're looking at water reuse back into your production facility, most times you're going to have to also look at RO technology after your aerobic MBR technology. That RO technology is really for salt removal. TDS, your sodium and your potassium and your chlorides will be removed in bulk using RO technology. You can see this RO technology is a tubular technology. It removes pretty much all of the remaining organic material and most of the dissolved inorganic material. These devices are typically skidded, as you can see here. They can be containerized if you need to put them outside, if you have no space inside. And they would go right after your aerobic MBR plant, or if you already have an existing plant, maybe it's a tubular UF followed by a tubular RO system. And these systems can be built in any size. These are standard products that go to as low as 20 or 30 gallons per minute and can go up to 600 gallons per minute in one standard skid. They come fat tested, completely controlled there with a control panel. Pretty straightforward system. So if you're looking at water reuse, you're going to have to probably think about RO to get to the quality level of water you're going to need to recycle back into a food and beverage facility. Next, we're going to look at an interesting technology which has some niche applications, and that is a evaporator technology. This is a technology which is a concentrator of material. So they are typically on pretty small flow rates, things that are 1 to 10, 15 gallons per minute. And you're looking at typically taking this at point source treatment. You're going back into your facility and finding where you have a very high concentration, low flow that is going down the drain. That you're going to treat before it hits the end of pipe, basically. It's a completely self-contained, shot fabricated system. It is what a lot of people refer to as a ZLD system. It can be put point source treatment in a food and beverage facility. It can be used to treat brine solutions that come off of a RO system in your plant or an IX system in your plant to treat that brine instead of sending it down the drain. And really what it does is it concentrates things up so you have a concentrate solution that has a much smaller volume. And then you have a condensate which is relatively free of salts. So where are people applying some of these types of technologies? First one we're going to look at here is an aerobic plant. This is a U.S. manufacturer of yogurt. You see typical flows here in the food and beverage industry, 200,000, 500,000 gallon peak. As we talked about before, you really got to understand your flows in the food and beverage world. You have average flows and you have peak flows. The system should be designed for both. You can see that BOD average, TSS average, FOG, this plant had that we had to deal with. You can see some of the phosphoruses and temperatures. This had to meet a sewer surcharge limit, in order for them to get below the sewer surcharge such that they're just paying on flow. So typically the first step we do is screen the wastewater for any larges, like your nuts and bolts, shrink wrap type of screen. Then we put some equalization in. You always want some level of equalization in your system because you want to size it downstream more for the average, not for the peak, because obviously you're designing for a peak. Instantaneous peak is going to increase the size of everything. Piping gets more expensive, pumps get more expensive, tanks get bigger. Typically, we recommend between 12 to 24 hours of equalization depending on your facility. The next step is through a DAF to remove the FOG. Then it goes into an MBBR system, which is for BOD removal. And then it goes through a Hydrotech filter for final TSS clarification. And as you can see, the final BOD limit there is 300 and TSS is 300. Second case study is a large confectionery producer in the United States. Much bigger system, 830 gallons per minute. And they wanted to go to very low levels of treatment, BOD and TSS of both less than 10. They needed to remove the ammonia down and phosphorus down. So this system had both BOD, TSS, nitrogen, and phosphorus treatment all required. We have a lot of different unit processes to get there. Again, your screening and EQ. Most wastewater treatment plants you'll see start with screen and EQ. Then we go into a biothane UASB, which is your anaerobic digester. That's going to remove about 85 to 90% of the BOD in the system. This facility takes that biogas, cleans it in an H2S scrubbing system, and then burns it in a generator, which basically makes power to self-power the wastewater treatment plant. After the UASB, the water is not clean enough to meet the discharge quality. So we go through a two-stage MBBR. The first stage is for BOD removal, and the second stage is for ammonia removal. So stage one takes the BOD down to a very low value. Stage two takes all the ammonia and nitrifies it into nitrate to take that ammonia limit down to where it needs to be. Then we do gross clarification with the DAF. Excuse me. The reason the DAF is chosen is because we have that waste solids that we have to deal with. So the good thing about a DAF is it concentrates up that waste float up into about 4 or 5%, greatly reducing the amount of trucks that are required to relieve this facility a day and not having the need for to have a dewatering. So if you had a traditional clarifier here, maybe you get 1.5–2% in your waste sludge TSS. So this the DAF is going to double and triple that, greatly reducing the truck traffic. Finally, we had to polish it for final TSS removal. You saw a TSS of 10. That's tough to get out of a DAF in one step. So you put a filter on as a polisher to get down to that 10 parts per million TSS. So this is a relatively large facility. If anybody'd like to go see it, we could go see that as a reference plant. It's got about all the technologies you could ever want to see in a wastewater treatment plant. Third facility, this is a high FOG facility. This is a snack producer that makes beef jerky. If you're familiar with the company that has beef jerky, that has the famous brand with the Yeti or the Sasquatch, that is this company. They have a facility which has about 150 to 60,000 gallons per day, 100,000 gallons per day peak. And since it makes meat processing, it has a lot of FOG in it. And they did not want to have a DAF in front of the system because they did not want to have to handle high levels of FOG. They did not want to have to deal with FOG removal through a truck on a daily basis. They're in a cold weather climate in the wintertime. They can have issues with getting snowed in and not having a truck be able to make it there. So they said, we want to digest that FOG, not have to deal with float removal. So we installed an membrane anaerobic MBR. So the advantage of this is we could digest their FOG, taking their FOG down to essentially 0, and meet their sewer discharge quality of less than 200 all in one treatment technology. We did not have to, if you were not going to do it this way, you would look at a DAF followed by an anaerobic system, followed by an aerobic system. So you would have had really a 3-part system. This gets it all done in one technology step. So it is a CSTR followed by membranes. As you can see here, they also took the gas and they ran it through a sulfur scrubber and again, put it through a generator to self-power their facility. So if you're looking at taking FOG and not just wanting to remove it with a DAF, but digest it, this is the type of technology that you would look at. Finally, we have a facility here that we're going to look at where they installed a point source evaporator. This is a candy maker in Canada. As you can see, the flow is pretty low, about 20 gallons per minute. This is a off stream that they have in their production facility. This is not in a pipe facility. They have a place in their plant where a bulk of their BOD they found out came from. So it's very low flow, but very high concentration. So they went into the facility. They source separated that one unique stream and they ran it through an evaporator. And the interesting thing here is after that evaporator, they have a distillate, which just goes down the drain. It contains very little BOD. And then they have their concentrate, which you can see we concentrated it up about 90%. And the interesting thing about that, since it's a food and beverage facility and it's been concentrated and it's been heat treated, they can sell that as animal feed. So you took a waste product that you were sending down the drain, paying large amounts of money in sewer surcharges or large amounts of money maybe in power in an aerobic plant, and they turned it into a valuable animal feed. So you turned a waste discharge into a profit maker. So that's how the economics of this plant were made to happen. So as we sort of round the finish line here, we're going to look about, hey, I'm thinking to myself, I might have a wastewater treatment project. What should I be looking at? What should I be thinking about? So who are the people out there that come to us with projects? One, where's your sewer surcharge? You know, how high are your, you know, what is your fees? You know, people come to us and say they have, you know, they're paying a couple $1,000s a month. It's tough to make a project go forward. But if you're paying high sewer surcharges, you could look at a pre-treatment to get yourself underneath that limit of maybe 200, 300, 300. Or do you have an existing treatment plant that has very high operational costs? Maybe you can have an anaerobic pre-treatment step that'll greatly reduce your power costs of your blowers, or will greatly reduce the sludge hauling costs that you have. Here's a big one. Are you getting NOV'd? Are you getting that little nasty piece of paper from the local sewer authority saying that you have a notice of violation? Your name maybe is in the paper. You're having difficulty maintaining your compliance. That's a reason why you might look at a wastewater treatment plant expansion or an upgrade to your existing facility. Is your municipality or your sewer surcharge, or maybe even your direct stream discharge, do you know new limits coming down the drain? I mean, are you hearing rumblings that they're going to all of a sudden put a nitrogen or a phosphorus discharge limit on you? Or maybe they're going to take your BOD or TSS limits down. A lot of times it's better to get out in front of this a little bit than wait to have them tell you what to do. Is your production plant expanding its capacity? Are they putting a new line in? Are they changing their product line such that maybe what they're putting down the drain is going to be a whole lot higher in flow or load? Do you have footprint problems right now? Do you need to recover some land maybe to use for better usage? Are you having difficulty operating your plant? Maybe your plant just needs some upgrades to it to make it much more easy to operate. So your operators don't have to come in on all hours of the night on nights and weekends, or you're not constantly battling as a manager, the problems down at the wastewater treatment plant, which are taking you away from your core business of making product. So what do you do? Well, simple thing is you call Veolia. I mean, that's what we do for a living. Our whole office in Philadelphia is about treating wastewater in the food and beverage industry. We've been doing it for 40 years. We have a lot of skilled people that can talk to you, have a planning level call, identify what the drivers are, what are your short-term goals, what are your long-term goals, what data do you have, what data do you need to collect? What are your sewer bills? What are your operational costs? I mean, in the end, what we can do typically is try to figure out, is there something there pretty quickly? We make money off of projects. We don't make money billing hours, trying to tell you and explain to you things that maybe you don't need. We like to look at things very quickly with our experience and say, hey, you know what? You think your sewer surcharge bill is pretty high, but in the end, if you got an ROI of 2 or 3 years, that means you only have a couple $100,000 to spend. And realistically speaking, you can't install a wastewater treatment plant for a couple $100,000. Or you have an existing treatment plant there and say, hey, you know what? You don't need a whole expansion. If you just turn this way and you added this widget here, we can probably upgrade your existing treatment plant for a whole lot less money than a new one. And we can do that pretty fast. So we also aren't just technology suppliers with respect to, we sell you a widget. We are excellent in understanding design bases and understanding existing wastewater treatment plants and looking at different technologies as an anaerobic technology, as an aerobic technology, as a DAF only. Do you want to digest your sludge or your float, or do you just okay with an operational cost? So we can give you a lot of different options from our technology toolbox in order to bring to bear what is best project for your production facility. So we do all of that on a daily basis. We have a lot of large customers in the food and beverage world, people that you know about, the Dannons of the world, the McCains of the world, the Hershey's of the world, the Anheuser-Busch's of the world, the Smuckers of the world. We have a lot of relationships with big people and with small vendors, with your smaller mom and pop 1 or 2 production facility. We get down in the weeds with them. And for some of these facilities, as we said, we can supply the technology, or we can design and we can install the plant if you would like. So we have different models that we can use with you to construct a project. Would you rather just hand this off to Veolia to design and construct it? Or would you like to do some of the engineering work yourself and just have us be a limited scope? So we're also very flexible on scope of supply as well. So that concludes our webinar here today on Wednesday afternoon. I hope everybody learned something or got some key pieces of information. At this point, TJ is going to open up to any questions that anybody has.
Great. Thank you so much, Greg, for that presentation. I just want to remind everyone, if you have some questions, we have the question panel to the right side of your screen. Go ahead and enter in the chat box there, and we're going to try to get to as many questions as possible. We received a handful of questions throughout the presentation. So we'll just start going through some of them. We have a couple about the annex colonist aerobic MBBR, Greg. Just a question would be, is talking about applying that technology in different climates, how well does that technology work in colder climates below freezing?
Actually, that technology does extremely well in comparison in cold weather climates. And there's a lot of these technologies. The technology was actually invented in Scandinavia, which is known for the cold weather climate. There's a lot of facilities up in Canada. We've done a lot of studies on cold weather nitrification down into the, 30-degree temperature range. The reason it is advantageous because you have your biofilm that grows on the media. So that biofilm can adapt to very cold temperatures at a much higher activity rate than just a conventional treatment plant. So actually cold weather treatment using the annex colonist MBBR is one of the places where it has a distinct technical advantage compared to most other systems.
Okay, and a similar question about that technology is, as it mentions the media that's used within that process. Can you talk about how long that's expected to live? Is it a consumable? And how often do you have to add to that media?
So the answer is not a consumable. I've always tried to tell ANOX that they should come up with a media that needs to be replaced every 5 years. They get a whole lot more operating revenue that way. But some of the first systems ever installed back in the 90s are still in operation today. No media has ever actually been added to the tank. So this is a plastic inert media. Once it's in there, it pretty much is in there for the life cycle of the facility. So it does not need to be replaced at any frequent basis. We've seen people take their tank down after 10 or 15 or 20 years, and they might have some broken media at the bottom. They might have lost 5% of the media over a 10 or 15 or 20-year period. But really, this media is in there for the life of the facility. So your tank will probably wear out before the media will.
Okay, and this is sort of a combination anaerobic aerobic question. When looking at different characteristics such as BOD, FOG, TSS, and such, how do you analyze to figure out what technology might be best used, or would it be both? Can you talk a little bit about the parameters and such for that?
Okay, so typically we require a COD of minimum, typically in the 3,000 ppm range to be anaerobic, be cost effective. There's a few opportunities that are maybe you can get down to 2,500 ppm, but they're typically more in the pulp and paper industry that have very high flows, so your total load is high. But in the food and beverage world, typically, once we see 3,000 ppm of COD, we start to think that anaerobic can be a viable candidate. Also, typically, anaerobic systems run at about 95 Fahrenheit. So if you have hot water, it lends itself more to anaerobic treatment. Now we can do influent effluent heat exchangers and use the biogas to do the heating as well. But the hotter the water comes down, typically the better. The more load you have, I mean, the more, flow times concentration is load. The higher load you have, the more anaerobic makes economic sense, because anaerobic makes economic sense because its operational costs are much lower. It has much lower operating horsepower. It has much lower sludge production. It has much lower nutrient requirements if you have to add N and P. It makes usable biogas. So the higher the flows and loads, the bigger the delta would be in an anaerobic system versus an aerobic system to make anaerobic be the proper choice. Aerobic systems are always required if you need to get down to very low levels of BOD and COD. I mean, anaerobic system traditionally can get 85 to 90%. So if you have to meet a 300 limit and you have a 5,000 ppm of COD and you get 90%, that's 500 ppm of COD left. So maybe you don't meet that limit in one step. So typically aerobic is always required when you need to polish a system down to very low limits, or if your COD levels are less than 3,000. That's traditionally where aerobic is going to be employed versus anaerobic. But since we do have both of those technologies, a lot of times we can go talk to people about both. We can say, okay, here's about what an anaerobic system would cost to install and operate, and here's what an aerobic system would cost to install or operate. and then you can look at what is the best economics of the situation. And a lot of times it's an economic decision between an anaerobic and an aerobic wastewater treatment plant if you're looking at at primary treatment and secondary treatment.
Okay, Greg, thanks for that. Just a couple of housekeeping questions that I've seen here about looking for the slides for today's presentation. Anyone who's attended this webinar will get an email tomorrow with a recording of the email to access that on demand. So you could review this presentation when you receive that tomorrow. Some additional questions that we have. Oh, this is interesting. Someone noticed that there's UV disinfection for the one case study we had for the chocolate manufacturer. Can you comment of why that was included?
Sure. That goes to the future proofing that we talked about, if you remember in the very beginning. You know, this particular customer was looking to build this wastewater treatment plant, not just for today, but for the future. And one of the things they were thinking about doing in the future was eventually potentially going to direct stream discharge. So if you go to direct stream discharge, it would be required to put a UV system in. So instead of waiting to put a UV system in the future, they recognized that they sort of got one bite of the apple for a capital appropriation, and they wanted to put a facility in that had flexibility to go direct stream discharge if they wanted to. So that is why that UV system was installed.
Okay, next question would be some tertiary treatment questions here. I have one. It asked is that a lot of times a clarifier is used downstream from biological systems, but there's installations, and mainly in Canada, this question comes from, is that where they don't see clarifiers installed below there. Can you talk a little bit about why some people might be omitting this, or is there methods for or standards to expect after a biological system for some kind of tertiary treatment like that?
So most aerobic systems require some type of clarification on the backside, other than if you have maybe a big aerobic lagoon type of situation. I mean, a traditional clarifier, whether it be a gravity clarifier or DAF, can get your TSS down, you know, depending on how big or you want to make it and how much polymer you sock to it, etc. You know, maybe 100 ppm or 50 ppm or something like that. Tertiary filters are typically put in place when you have to get down to very low levels, you know, sub 20 ppm, sub 10 ppm TSS. So they're typically installed after an existing clarifier or in a situation, if it's a greenfield site, you know, after a clarifier, to get polish what comes out of a clarifier to meet extreme low levels of TSS, or you would put them in if you sometimes need to remove phosphorus. So you can dose some ferric chloride before the filter to drop your phosphorus levels down to extremely low levels. I mean, there's systems out there that have pre-treatment for phosphorus that are getting phosphorus levels down less than 0.5 ppm. So if you have to meet extreme low levels of TSS or extreme low levels of phosphorus, that's where typically you will see the Hydrotech filters employed in a wastewater treatment plant.
Okay, another question, some of that is, can the disc filter replace a sludge filter press? Particularly this attendee treats around 500 cubic meters of secondary sludge with their filter press. Can you comment on that?
No, the filter press is a dewatering device that takes waste sludge and, you know, dewaters it typically to like 20-25% TSS. The Hydrotech filter is going to take an influent that maybe has 50 to 100 or 200 ppm TSS and bring it down to 10 or 20 parts per million TSS. It's not a sludge concentrator per se. It is more of a TSS remover device. So it is not a concentration device like a filter press or a belt filter press. Different applications.
Okay, going back to the MBBR, the Anaxconus MBBR, the asker said that there is a range of media from 200 to 5,000 meters squared per cube Is there any comment on which would be the right type of media to use?
So yeah, a lot of different vendors have a lot of different claims per se for, for really it's typically it's meter squared per meter cubed. So how many meter squared of surface area do you have per meter cubed of media volume? There's typically in most food and beverage applications, we use one of two types of media. There's the standard media, which is out there, that most applications use. And then we have a specialty media called the Z-chip media, which is really for high precipitation applications, mainly in some of the dairy industry, specializes in the dairy industry. I would say that when you look at surface area claims, they're claims. It's just a little bit of a marketing type of thing, that my media has more surface area than your media. And it's a lot about how do you measure that area and what units are you using. And there's a certain point where if you have, you can only have so much surface area on a cubic meter of media before it just is the law of diminishing returns. So they might say they have X thousand, but really only 500 is usable area anyway. So when you look at a system in MBBR, you should be concerned less about how much square meters per meter cubed of surface area do you have, and you should look at more about performance guarantee across the system and size of the reactor tank. So if I have a flow of X and a BOD of Y and I need to meet a certain discharge, what will that technology vendor size of their tank be, and what guarantee will they give on the discharge, and what does it cost for those internals? So I would look less at meter squared per meter cubed of media and look more at the cost of the tank and the system itself and the guarantees that will be given, because the other stuff is really just marketing, a little bit of marketing mumbo jumbo in my mind.
Okay. Well, in respect for everyone's time, it's about 3 o'clock. I want to get off and be mindful of everyone's schedule. Just want to remind everyone that to take the survey after today's webinar for that chance to win that Amazon gift card. Also, if you want to visit our website, this presentation, along with several other, will be available on demand. And you can also take a look at the future webinars that we have scheduled over the next couple weeks for you to join in on those as well. I would like to first thank our presenter, our panelist, Greg Rosenberger, for today's presentation. And then lastly, I'd like to thank everyone who spent an hour out of their day to join us for this webinar. We hope you enjoyed it, and we hope to see you again soon in one of our future broadcasts. Thank you all, and have a great day.